So this is section 1.7, midpoint and distance in the coordinate plane. So the objectives are we're going to be able to find the midpoint of a segment and find the distance between 2 points in the coordinate plane. So let's get started. First, let's review with midpoint. How do we find the midpoint? So if I have point A is at 5 and point B is 11, what do I do to find that? So you can remember that the midpoint is going to be equal to point A plus point B divided by 2. So we're just going to take the average. So that's going to give me 16 divided by 2, or the midpoint is going to be 8. So we have the midpoint at 8. And I can double check because this is a small segment. 5, 6, 7, 8, 9, 10, 11. So the length of this segment is 6, so we'd write that AB equals 6. Now let's suppose we want to find the length of segment AB. So, what am I going to do? It's not on a number line. I can't just count where it is. So I'm going to have to do, would you agree that A, this little green line right here, is on the x-axis. It follows the x-axis. And the blue line follows the y-axis. So if I find the midpoint of the green line and the midpoint of the blue line, when I combine those, I'll have the coordinates for the midpoint of segment AB. Because this green line would give me my x value and the blue line would give me my y value. And I could just plug that in and I would know what the coordinates were. So over so many for x, up so many for y. Okay, now stay with me on this part. We're not going to be using numbers, so it's going to make it a little more confusing. So let's say that this is y sub 1. And this top part up here is y sub 2. And we'll do the same with our x. So we'll say that this point is x sub 1. And this point is x sub 2. So to find this midpoint, to find the x value, we're going to say x sub 1 plus x sub 2 divided by 2. And then to find the y value, we're going to treat the y sub 1 and the y sub 2 just like their numbers, just like we did with x. So we're going to say y sub 1 plus y sub 2 divided by 2. And that is going to give me my coordinates. So the midpoint is equal to x sub 1 plus x sub 2 divided by 2, comma, y sub 1 plus y sub 2 divided by 2. And that's going to give me my coordinates. So now let's take a look at this example. Segment AB has endpoints at -4 and +9. What is the coordinate of its midpoint? So the first thing I'm going to do is I'm going to look and I'm going to say, oh, I'm working on a number line. I don't have to worry about the x and y value. So what do? I add the 2 points, so -4 plus 9, and I divide by 2. So that gives me 5 divided by 2 or 2.5 units. Now let's take a look at another example. Segment EF has endpoints of E, 7 and 5, and F, 2, negative 4. What are the coordinates of midpoint M? Okay, so the first thing that I'm going to do is I'm going to draw the little line. So that helps me visually, so I can see the points right here. So I'll say my Y value is 5, and then over here my Y value is negative 4. So now I'm going to take a look at this blue line. I've drawn it in already. And let's see, what is my X value for this part right here? Okay, so my X value is 2, and my X value over here is 7. And notice, I didn't just look at the graph to get these. I got these numbers from the coordinates that they actually gave me. So, let's find the midpoint. So we're going to need coordinates to find this midpoint because it's on a coordinate plane, so it's not just a number line. So we're going to do our X values first. So we're going to say, okay, we've got 2 plus 7 divided by 2, comma, 5 plus negative 4 divided by 2. Okay, 2 plus 7 is 9 divided by 2. And 5 plus a negative 4 is 1 divided by 2. So my coordinates for this point are going to be 4.5 and 0.5. So let's go ahead and plot that point on the diagram. Let's see, I'll use this color. So I'm going to go over on my X value. Let's see, 3, 4, and a little bit, 4.5. I'm going to go up a half. So the midpoint is right there, the little purple dot. Now let's take a look at an example without a graph. So it gives me all of the information I need. So what is the midpoint of segment RS with the endpoints of R? The coordinates are 5, negative 10, and S, the coordinates are 3, 6. So we are going to say that the midpoint is equal to 5 plus 3 divided by 2, comma, negative 10 plus 6 divided by 2. So that simplifies down to 8 divided by 2, or we could simplify that further down to 4. And negative 10 plus 6 gives me a negative 4 over 2, which simplifies down to a negative 2. So the coordinate for the midpoint is equal to 4, negative 2. So here we have an example where they give us the midpoint and they want to know what one of the other endpoints is. So they give us the midpoint and an endpoint, but they're looking for the second endpoint. So what we're going to do, we're going to set this up using our traditional setup. So we're going to say negative 2, comma 1 is equal to, so now what I'm going to do is I'm going to break it up into two parts. So the first one I'm going to look at is the x. So I'm going to say negative 2 is equal to negative 5 plus x sub 2 divided by 2. And then I'm also going to break it up into this part for my y value. So 1 is equal to 7 plus y subscript 2 divided by 2. So now I'm going to go through and solve. So I need to get rid of this 2 right here, the 2 in the denominator. So I'm going to multiply both sides by 2. Because remember, whatever I do to one side, I have to do to the other. So I have negative 4, these cancel out, is equal to negative 5 plus x sub 2. I'm going to add 5 to both sides. So 1 is equal to x sub 2. So I have my x value. Now let's see if we can find my y value. So again, I'm going to multiply both sides by 2 to get rid of that denominator. So 2 times 1, that gives me 2 is equal to 7 plus y sub 2. Going to subtract 7 from both sides. So negative 5 is equal to my y value. So point D has the coordinates of 1, negative 5. So the next thing we're going to use is the distance formula. And the distance formula should look pretty familiar. It's just in a different format. It's based off of we get the distance formula from the Pythagorean theorem. A squared plus b squared equals c squared. So all we're doing is we're taking the square root of a squared plus b squared so that we can get our value c over here. Notice that over right here, we are finding the length of side A, and right here, we are finding the length of side B. Okay, so remember, distance is equal to the square root of a squared plus b squared. So it doesn't matter which point you label x sub 2 or which x coordinate you label as x sub 1, as long as you're consistent in the order. So what I typically do is I write it up here. That way everybody knows what's going on. So y sub 2, y sub 1. So notice that my x sub 2 and my y sub 2 are together, and my x sub 1 and my y sub 1s are together. Okay, so the distance is equal to the square root of negative 7 minus 4 squared plus y sub 2 is 5. 5 minus a negative 3 squared. So d is equal to the square root. See, negative 7 minus 4, that gives me negative 11 squared plus 5 minus a -3. So that's going to give me 8, because remember, two negatives make a positive, squared. So D is equal to the square root, the square root of 121 plus 64, which is equal to the square root of 185. And when I plug that in my calculator, I get the segment UV is equal to 13.6 when we round it to the nearest tenth.